After talking about Taylor polynomials, now we want to talk about what a Taylor series is. So keep in mind that a polynomial is finite. A polynomial has a specified number of terms in it. But now that we know a lot about series, we're going to look at infinite series. So when we set up our Taylor polynomial, this was our pattern. But we can write that as an infinite series. And we are going to start at n equals 0 instead of n equals 1. Because if we don't start at n equals 0, that first term is going to be dropped. So we want to make sure that we're careful with that. But then we're going to use this term, which we call either the general term or the nth term. And we're going to set this up as f to the n of c over n factorial times x minus c to the n. Now that's an infinite series. And what happens is obviously because we're starting at an index of 0, if I plug in a 0 here, I get f of c, and then that would go away because anything raised to the 0 power is 1, and 0 factorial is also 1. So then we would have f of c, and then the next term would look like this. Then the next term would look like this. So this is my infinite series. That is a Taylor series. Instead of a Taylor polynomial, we're going to call it a Taylor series. If the center is at 0, we call it a Maclaurin series. We still can build it the same way, but now we want to know what the series expansion is instead of just a finite number of terms. So we'll set it up as f of x is equal to e to the 5x. Our center is going to be at x equals 2. And then, of course, we're going to have the first derivative and the second derivative. The first couple will probably be enough for me, but it does want the first 4 non-zero terms. So I guess I'm going to need one more here. So we'll do the third derivative as well. So pretty easy derivatives, 5e to the 5x. 25e to the 5x, 125e to the 5x. But then we're going to have what we're going to call our general term or our nth term. So let's look at the pattern of this. We basically had 5 to the 0, then 5 to the 1, 5 squared, 5 cubed. So that follows the derivative. So we're going to say this is 5 to the n, but then the e to the 5x is always there. Now, obviously, we're concerned with the center. So we want to make sure we know that at x equals 2, we're saying this is e to the 10th, and this is 5e to the 10th. This is 25e to the 10th. So at x equals 2, we're going to be looking at 5 to the n e to the 10th. Instead of e to the 5x. Now, don't forget about your extra terms, right? Your polynomial pieces. What makes this a Taylor polynomial is that extra stuff, that x. So there was an x minus 2 here. Technically, it's raised to the 1 power, but we didn't need it. Then this is going to have that x minus 2 squared over 2 factorial. And then this is going to, I'm multiplying these, right? This is that Taylor series term over 3 factorial. So again, applying this to the nth term or the general term, it's going to be x minus 2 to the n over n factorial. So this is a pretty common prompt to ask for a certain number of non-zero terms and then the general term. So we're going to set this up. I'm going to call it t of x because it is the Taylor series. And it didn't, I can approximate f of x this way, right? So I can set it up that way. But sometimes it's nice, same way we did with polynomials, we used a p. I could use a p as well, but because I'm going to keep going to that nth term, sometimes we use a t. And we're going to set it up as e to the 10th plus 5e to the 10th times x minus 2. That's 2. I need my third non-zero term. I'm going to go ahead and move down a little bit. Plus, this is my fourth. This is my fourth non-zero term. And then you want your general term. So we want to make sure that we get the ellipses in there to indicate that we continued on till we got to 5 to the n, e to the 10th, x minus 2 to the n over n factorial. And it does keep going, but that is what we would set up as our Taylor series. Now, if we wanted to write it in just series notation, we could do that as well, but that's not what the prompt asked for. But if we wanted to write it in series notation, we could set it up. Oh, I forgot the x minus 2. We could set it up like that. So you may see it written that way as well.